Hello there and welcome to Year 9 end of year exam revision. Here we're going to go through the third of 4 exam revision videos, and in this video we're going to go through questions 7, 8 and 9. So in this video, at each question, pause the video and answer the question. Have a proper go at the question and try really hard on it. Don't just give up after 20 seconds. Play the video to see if you were correct, and then if you weren't, then try to remember what you need to do next time so that you know how to do it next time, and then also try the question again the next day until you get the question correct. So in this video we're going to go through questions 7, 8 and 9 from the end of year exam. In this video we're going to revise circle theorems, trigonometry and mode, median and mean. You can watch these Maths Watch clips if you want, or you can carry on and watch this video and go along with some questions with me. Now just a reminder of the circle theorems. We have the first circle theorem here, which is that an isosceles triangle is formed when you use two radiuses and then a line that connects those two radiuses at the circumference together. And the rule here is that the angles are equal inside those isosceles triangles. So we've got two equal angles here if you've got two radiuses. You know that you've got a radius if you've got a line that goes from O, which is referred to as the origin, to the circumference. Another circle theorem is that if you've got a quadrilateral inside a circle, and that's called a cyclic quadrilateral, cyclic for circle, quadrilateral for quadrilateral, so it's a special type of quadrilateral that fits perfectly with its vertices on the circumference of a circle, then what you'll actually find is, yes, all the angles will add up to 360. That always happens for every quadrilateral, but especially for a cyclic quadrilateral, these two angles here will add up to make 180. So the opposite angles will add to make 180. You could say here that A plus B equals 180. And also with x plus y as well. Those two are opposite angles as well. So x plus y will add up to make 180. Another circle theorem for the end of year 9 exam is that whenever you have a diameter, that's a line that goes from one side of the circle to the other through the origin, then any triangle that you make with that diameter with another point on the circumference will have a right angle in it, and it will be that the right angle will be at the circumference. So there will be a right angle triangle if you make a triangle with the diameter and another point on the circumference of the circle. The way that I like to phrase this circle theorem is an angle subtending the diameter is a right angle. So what I mean by subtending is that take either side of the diameter, make yourself an angle with that onto the circumference, and that angle there will be a right angle. So it's coming off of either side of the diameter. Moving on to the next circle theorem, angles subtending the same chord in the same segment are equal. So what I could do here is if I make my chord along here, I sometimes refer to this as the bow tie theorem because it kind of looks like a bit like a bow tie, doesn't it? Then if the chord is along here, then this angle up here is equal to this angle up here. Also, if I move my chord to the top of this diagram, then this angle down here and this angle down here will be equal, because if we take this chord, if we take both corners of this chord and make triangles out of that chord, then the two angles that you create are equal to each other. So the phrasing of this circle theorem is that angles subtending the same chord in the same segment, that just means you can't go up, you have to come the same side of the chord, then they are equal. And then the final circle theorem we have to remember here is that arrowhead circle theorem, whereby if you've got a shape that forms similar to an arrowhead with a point at the centre, has to be at the centre, then the angle at the top, double it, you'll get the angle at the centre. So this is angle at circumference is double, angle at centre is double the angle at the circumference. And sometimes it looks a little bit weird, it looks a bit skewed. For example, if we pick up this point at the top of the arrowhead and move it round to here, then it's still the same angle rule, but it doesn't really look like an arrowhead anymore. So you don't use the arrowhead theorem as a title for it. You use the rule angle at the centre is twice the angle at the circumference. Alright, let's have a go at these questions here then. So pause the video and give this question a go. Okay, on the third question here, probably what we want you to do is work out this angle in the corner X there. So let's get started on the first one. If we put a chord along here, then the angle coming off of this chord will be 35 degrees, and the angle X, just in a different position, so X equals 35. Also, if we do this in a slightly different way and we put the chord up here and we make an angle with 63 degrees, and with the Y angle, then Y will have an angle of 63 degrees because it will be the same angle for any angle coming off of this chord here. So if I make this angle, that'd be 63. If I make this angle, that'd be 63. If I make this angle, that'd be 63. If I make that angle, it'll be 63. Any angle that comes from this point here and this point here to any other point on the circumference will all have angles 63 degrees. Let's move on to the next one, and the next one is the isosceles triangle rule. In an isosceles triangle, the two angles at the circumference are equal, so that angle there is also x. And we know that angles in a triangle add up to 180. So the first thing I'll do is 180 minus 98, and that will give me 82. So I've got 82 degrees to share between these two angles. So it's going to be 82 divided by 2, which is 41. So 41 degrees is the answer for x in question 2. And then in question 3, we have a line that's going from one side of the circle to another. That's called the diameter. So this angle at the top here is a right angle. So what angle is left over? It's going to be 180 minus 36 minus 90 degrees. And let's do that on the calculator just to make sure I haven't got it wrong. 180 minus 90 minus 36 is 54. And there we are. That's the answer to question 3 here. Let's move on and do 3 more then, testing different circle theorems. Pause the video and give these 3 a go. Okay, let's move on to the angle down here. Now this angle here needs to be doubled to get this angle here. So x is going to equal 104 degrees. That's the circle theorem you need there. In question 2, it's the opposite angles that will add together to make 180. So this angle x up here is going to be 108 degrees, and then angle y is going to be 94 degrees. And moving on to question 3. Question 3 is a little bit tricky, this one. You actually have to go to the top angle first. So you first have to go from 126 to this angle up here. That's going to be 63 because you halve this angle to get 63 up here using the arrowhead theorem. Then you change your point of view and you look at this now as a quadrilateral, and the opposite angles in a quadrilateral add up to 180. So x is going to be 180 minus 63, which will be 117 degrees. So there we are. We had to combine 2 circle theorems for this question here. We had to use, first of all, this first circle theorem on the left, whereby we have to use the arrowhead theorem. The angle at centre is double the angle at circumference. And then we had to use the angle, opposite angles in a cyclic quadrilateral add to 180 to get the angle x down the bottom. So there we are. That's the answer to this question. Okay, so let's move on to a more exam type question now. Calculate the angle LOP. So what does it mean, LOP? Well, it means you start at L, then you go to O, and then you go to P. And it's the angle that you create from going from L to O to P. So it's this angle here that we're looking for as the answer to this question. So it's one of these weird ones where it's the arrowhead theorem, but it doesn't quite look like the arrowhead theorem. Think about it, if we were to move this point M up to the top, then it would start to look like an arrowhead theorem. But it doesn't quite look like an arrowhead, but it still is the same rule. Angle at centre is double the angle at the circumference. So you double 48 to get x. So x equals 96 degrees. And the angle rule that we use there is that the angle at centre is double the angle at the circumference. Okay, let's move on to the next one. Calculate the angle ODC. So O to D to C. Okay, so we've got a lot of different rules that we could use here, but I'm not too sure how we would get straight to the answer ODC. So I suppose what I could do is I could just start working out different angles, and then hopefully I get to ODC. And what I might have to do with ODC is I might have to break it down into this angle and then this angle, and then add the two angles together. We'll have to see as we go through the question. Now, what can I spot first of all? Well, I'll spot the arrowhead theorem. I can use the arrowhead theorem on ABOD to work out that this angle here is 150 degrees. Then I can spot ODB is an isosceles triangle because it's got a point at the centre and these two lines go to the circumference. So therefore these two angles, one here and one here, must be equal to each other. Now if the angles in a triangle add together to make 180 degrees, I've got 30 degrees left over to share between these two equal angles. So these two angles here must be 15 degrees each. So I've got part of this angle now. ODC, I've got part of it is 15. Okay, let's now have another look at it, and I can see myself a quadrilateral forming around the ABCD of this quadrilateral. And opposite angles inside a quadrilateral add together to make 180. So I can put 75 together with this angle here to make 180, so that must mean that this angle here is 105. Then I can work out this angle here from this triangle on the left hand side, so that's going to be 180 minus 27 minus 105. So if I minus the 105 first, I'm down to 75. If I take away the 7 next, that would get me down to 68, so that would be 48 degrees. So this angle here is 48 degrees. So the total answer to this question is 48 plus 15. So add the 5 on the first, that will get us to 53. So that would be 63 degrees as the answer to ODC. Okay, let's move on to question 8 now. Question 8 is on trigonometry. So what I'd like you to do is pause the video and have a go at these trigonometry questions. Okay, so can you remember how to do trigonometry? That's the question. So remember, with trigonometry, there's that helpful little acronym, SOHCAHTOA, and it's always very helpful to remember that. It's so helpful, it's in exactly the right order that helps create my SOHCAHTOA equations. And it's also helpful to be able to label up a right angled triangle. So if this here is the angle in the question, don't worry about the right angle. Yes, there has to be a right angle in a trigonometry question, but the key angle for this question is the 37 degrees. Then this side over here would be what we refer to as the opposite side. It's opposite the side where the angle is, so this is the opposite side. This side here is the hypotenuse, but we're not going to really use that for question 1. And then this side here is the adjacent side, the side that's left over, and it's always next to the angle that you have for your question. So what do we have here? We have a hypotenuse, so we have an opposite side, and we have an adjacent side. So we have O and A. So let's look through SOHCAHTOA, and it's TOA that has both O and A in the little acronym. So we're going to be using T in this question, T for tan. So you write down tan 37 equals, and then you have to create a fraction, and the fraction appears in the order that the letters are in SOHCAHTOA. So it's opposite divided by adjacent in that order. So it's going to be x divided by 9. The next thing we do is on our calculator type in tan 37. So tan 37 equals 0.754 equals x divided by 9. And now we just need to rearrange it to make x equals. So at the moment x is being divided by 9. So if I times both sides by 9, that will get rid of the divide by 9. So what I'll do now is on my calculator, I'll do 0.54 times 9. But I won't type in 0.54, I'll type in answer button, because the current answer on my calculator was the exact number of 0.535 times 9, and that will give me 6.78. So 6.78 centimetres is equal to x. And there we are, that's the answer for the first question. And let's move on to the next one. So in this question, this is our angle, 59 degrees. In this question, this side is the opposite side, because if you imagine that you're in this corner here and you're looking opposite, then this is the opposite side. It's opposite to the angle you're working with. The longest diagonal side is always the hypotenuse, and then this side here is the adjacent side. So in this question, we're working with opposite and hypotenuse, so that's going to be O and H, and SO has both of those letters in it. So it's going to be sine. Sine 59 equals, and then you have to create the fraction in the correct order of the acronym. So it's opposite divided by hypotenuse. So that's going to be 5 divided by y. So let's type onto the calculator then. Sine 59 equals 0.857. Then we need to rearrange it to make y the subject, and y is being divided here at the moment. So we're going to need to times it onto the other side. This one's a little bit more tricky to rearrange. So it's going to be 0.857y equals 5. And then we divide by that decimal number, so 5 divided by 0.857. So on my calculator, I'll now write that out, but I'm not going to be using the number 0.857. I want to use the exact decimal of 0.85716730007. So I'll have to type out 5 divided by the answer that was my answer to sine 59, and I get exactly the correct answer of 5.83 centimetres. And there we are, that's the answer for this second question. So you can see here two different types of question. One where it's a bit easier, where the missing letter is on the top of the fraction, and one where the missing letter is on the bottom of the fraction. And you have to do a little bit more work to rearrange it when the letter that you're trying to find is on the bottom of an equation. Alright, then pause the video and give these two questions a go. Okay, so always try and remember SOHCAHTOA. It's not given to you in an exam, so you do have to remember it. And it's always good to just write it down at the start of a trigonometry question. So in this question, we have this side being the opposite side, this side being the hypotenuse side, that's the diagonal longest side, and then this side left over is the adjacent side. It's next to the angle. This one's the angle. So what do we have here? We have the adjacent and hypotenuse involved in this question, and it will be cos that we're going to use for this question because it has both A and H in the acronym. So we're going to write down cos 71 equals, and then the fraction if created by the letters in the correct order. So A divided by H. So it's going to be adjacent, which is x, divided by 11. And this is an easier question because the x is on the top. Then I'll actually work out what cos 71 is. Cos 71 is 0.326 equals x over 11. And what that 0.326 means is that the ratio between this side and this side is in the ratio 0.326, or in other words, take this longer side, multiply it by 0.326 and you'll get x. So do this adjacent side divided by the hypotenuse, you get 0.326 when the angle is 71. So to rearrange this now, x is being divided by 11, so I'll need to times it by 11 to work out what x is. So do answer button times 11, and we'll get 3.58 centimetres. And there we are, that's the answer for x. Moving on to the next question, this angle is our angle we're working with. This side will be the opposite side, and this side will be the adjacent side. So we're back to O and A, which will be tan. So it'll be tan 35 equals, in the correct order, O divided by A, which will be 9 divided by Y. Slightly harder question because the missing letter is on the bottom. So let's work out what tan 35 is. Tan 35 equals 0.700. Okay, to rearrange this, we need to now multiply both sides by y. So it'd be 0.7y equals 9. And then to get y on its own, we need to divide by 0.7. So it's going to be y equals 9 divided by 0.7. But I'm not going to write 0.7 on the calculator. I'm going to use the answer exact value of tan 35. So that's going to be 9 divided by answer, which is 12.85. And there we are. That's the answer to this question. Let's move on to the next one. We'll have a few more then. Pause the video and give these questions a go. Okay, so what you'll notice in these questions is that in this question we're trying to find the angle rather than trying to work out a missing side. So this is where we have to use sine -1, cos -1 and tan -1. So in this question we're trying to work out this angle and we're given the opposite side and the adjacent side. So how do we know which one out of sine, cos or tan to use? Well, we've got to always remember SOH, CAH, TOA. And in SOH, it's tan that has both O and A in it. So it's going to be tan -1, and then you put the fraction in the correct order, opposite divided by adjacent in the order of TOA. So it's going to be 4, because that's O, divided by 9, because that's A. So tan -1, you have to press shift and then tan on your calculator. 4 divided by 9, and that gives you 24.0 when you round it to 3 significant figures. So that won't be centimetres, that'll be degrees. So the answer here was 23.96. Now if we're rounding to 3 significant figures, the 6 here will round the 9 up to a 10, but you can't really put 23.10. You have to put the 1 onto the next figure to make it 24.0. So 24.0 is the answer to this question, 24.0 degrees. And moving on to the next one, we need to work out this angle up here, y. So we need to label the sides first. This is the adjacent side, this is the hypotenuse side. So we're going to be using cos for this question. Cos -1, because I'm finding an angle in the correct order of CAH, so it's A divided by H, 5 divided by 8. So let's do that on the calculator. Cos inverse 5 divided by 8 equals 51.3 degrees. And there we are, that's the answer to this question. So you have to use tan -1, cos -1 or sine -1 when you're working out an angle. Okay, a little bit of a problem solving question here. Pause the video and try and give this question a go. Okay, so this question is work out the area of this isosceles triangle. Well, this isosceles triangle is not a right angle triangle, obviously. But how can we create a right angle triangle? Because we can only do trigonometry with right angle triangles. Well, what we can do in this question is we can split it down the middle to work out the height. Why would you want to work out the height? Because the formula for an area of a triangle is base times height divided by 2. I don't know what the height is yet. I know what the base is, but I don't know what the height is. And it's really important that I work out the length of this red line so that I can work out the area as base times height divided by 2. So what I'm going to do here is I'm going to use a right angle triangle on the left hand side. So this here is going to be my right angle triangle. And the base of this triangle is going to be 5 centimeters because I've had to cut this 10 centimeter line in half. So I've got a 5 centimeter line. I've got the angle of 70 degrees. And I also need to work out this side here, H. So what would the labels for these be? Well, this would be the adjacent side of the triangle. And this would be the opposite side of the triangle. Yes, we've labelled it as H for height, but it's not the H for hypotenuse. So don't get height and hypotenuse mixed up in this question. So it's opposite and adjacent. Therefore, we need to use tan. So it's tan 70 equals, let's type that into the no, actually no, you do the fraction first, don't you? So it's going to be TOA. So it's going to be tan 70 equals opposite, which is h, divided by adjacent, which is 5. So h divided by 5. Let's now work out what tan 70 is. Tan 70 equals 2.75 equals h over 5. Now let's multiply both sides by 5. So 2.75 times 5, but I'm not going to write 2.75 in the calculator. I'm going to use answer button times 5 equals 13.7. So the height of this triangle is 13.7 centimeters. That's not the final answer to this question because we need to work out the area of the triangle. So I'm going to use area equals base, which is 10. We have to go back now to the whole base, which is 10, times height, which is 13.7, divided by 2. Now on my calculator, I'm not going to write down 13.7 because I've currently got the actual answer of 13.7373871 stored as the answer button on my calculator. So on my calculator, I'm going to type in the fraction button, then 10 times answer divided by 2, and that gives me an answer of 68.7. And what will the units be? It's in centimetres, so it's going to be centimetres squared because that's the unit for area. So there we are, a little bit of a problem-solving question with trigonometry there, working out the area of an isosceles triangle. Alright, let's have a go at a similar question here. Pause the video and give this one a go. Alright then, so hopefully you've worked out that you need to divide your isosceles triangle in two. Because to work out the area of an isosceles triangle, you need to know the height. So, when I've divided this in two this time, I've got an angle of 60 degrees on both sides, and a side length of 9. So if I draw this left-hand triangle out again, without all the mess, I'm going to have an angle here of 60 degrees, and an angle of, and a side of 9, a right angle here, and I need to work out the height of this triangle here. So I can do base times height divided by 2. So what do I have in this triangle? I have the opposite side, and I have the adjacent side. And that again is tan. So tan of 60 equals, and then I'll create my triangle by doing it by writing out the fraction in the correct order. Opposite divided by adjacent, so it's 9 divided by h. Let's type out tan 60 on the calculator, and we get root 3, but I think it'd be better if we write 1.73. So it makes a bit more sense. Alright, so now what we need to do is we need to now multiply the h onto the other side, because this one's a little bit more difficult to rearrange. And then divide by the 1.73. So we type into the calculator 9 divided by 1.73, and that will give us 9 divided by, I shouldn't have written 1.73 into the calculator, should I? I should have used the exact value of tan 60. So I'll do that again. I'll do 9 divided by answer button, and that will give me 3 root 3. I'll press S to D to turn it into a decimal, 5.20. Now that's not the answer to this question, that's the answer to what the height is, but I need to work out the area for this isosceles triangle. So I'll now do base times height divided by 2. Remember that the base of the whole triangle is 18, so it's going to be 18 times height, which is 5.20, divided by 2, and I'm going to use the answer button for 5.1961522423 in the calculator, so I'm going to put answer button here. So it's going to be fraction button 18 times answer divided by 2 equals, and I get 27 root 3, or 46.8. 46.8 centimeters squared. When you get a bit more advanced with your maths, you will actually write 27 root 3 as your answer to this question. But for now, it makes a bit more sense if we just have this as a numerical answer. Alright then, let's move on to the next question. And it looks like we've got a bearings question here. Oh, my class absolutely love bearings. So, Jodie is riding her bike to school. She travels 8 kilometres west and then 10 kilometres south. So let's just draw out what north, east, south, west are first. So it'll be north, east, south, west, just to make the question a bit easier. Jodie's mum collects Jodie from school in a helicopter and flies straight home. Calculate the distance to travel home and then the bearing to travel home. So let's write out Jodie. We'll put Jodie in the middle of the page because I'm not too sure which way she'll go. She travels 8 kilometres west. Okay, west is to the left. So 8 kilometres in that direction and then 10 kilometres south. So 10 kilometres south. So Jodie ends up here. And this is school, so I'll put S here. So Jodie's mum collects Jodie from school in a helicopter and flies her straight home. So straight home to Jodie's house. Calculate the distance to travel home first. Okay, well the answer to part A is not a trigonometry question. Can you work out what type of question it is? It's a Pythagoras question because we've got two sides of a right angled triangle and we want to work out the hypotenuse. So it's going to be 8 squared plus 10 squared, all square rooted, because remember you need to square root after a Pythagoras question. So 8 squared plus 10 squared gives us 12.8. So 12.8 kilometres home for Jodie in a helicopter. Lucky thing. Now we need to work out the bearing that she travels home. So the bearing is, if she's at school, then it's the angle. If we measure from north, now north would be in this direction here, it would be the angle measured clockwise round until we get to the line that Jodie will travel home on. So it's this angle here that we need to work out. Bearings are always measured from north and they always go clockwise round to where they want to go to. So in this question here we'll have to work out x, and we've got two sides of our right angled triangle. We've got the opposite side and we've got the adjacent side. So what trig function needs opposite and adjacent? It will be tan. So it's going to be tan. Now we want to find an angle, so it's actually going to be tan minus 1. And then you write it in the correct order. So it's TOA, so it's opposite divided by adjacent. So 8 divided by 10. So tan inverse 8 divided by 10 gives us 38.7 degrees, 38.7. Now generally actually you don't write bearings with decimals in it and you write it with 3 figures. So the actual answer to this bearing, you round to the nearest degree, 039 degrees. It's always written with 3 figures bearings and you generally don't put decimals in it. So there we are, that's the answer to this question. Alright then, and another question on trigonometry here, but 3-dimensional trigonometry this time. Find the lengths of the following to 3 significant figures. So it's not a length, is it? It's an angle, but it's find the angle HAD. Okay, so let's draw from H to A to D. Okay, so we need to work out this angle here. Now what might be helpful in this question is if we draw out that diagram. So we have A in the corner, and then D at the bottom, and then H at the top. Now what dimensions do we know about this question? Well, we know it's going to be 4 from A to D, and we know it's going to be 6 from D to H. And we need to work out HAD, so we need to work out this angle here. So in this question we're going to have the opposite side and the adjacent side, so again it's tan. We're working out the angle, so it's tan minus 1. And it needs to go O divided by A, so it's 6 divided by 4. So tan inverse 6 divided by 4 equals 56.3. And that's the answer to to this question. Let's move on to the next one, DAB, so DBA rather, so from D to B to A, so it's going to be this angle here. I use a different letter, I use Y. So let's draw it out so that we can help visualize it. The longer line down the bottom is 10. The angle here is Y, B is here, D is here, and A is here. And what other angle, what side do we know? We know that 4 will be the distance from D to A. So 4 will go here. And we need to work out this angle here. And again, we have the adjacent side and we have the opposite side. So again, it's going to be tan. Tan minus 1, because we're finding an angle. And then make sure you do the fraction the right way around. It's opposite divided by adjacent, 4 divided by 10. So tan minus 1 of 4 divided by 10 is 21.8 degrees. And there we are, that's the answer to part B of this question. So with three-dimensional trigonometry, it's sometimes a good idea to write out the triangle that you're working with and then add the labels to the triangle yourselves. Alright then, we're now on to mode, median and mean. So let's have a go at this question. Make sure you've paused the video and given it a go. So the table gives information about the number of minutes Paulina used her mobile phone each day in November. Work out the class in which the median value lies and calculate an estimate for the mean. So moving on to part A first, the median, so that's the middle value. So if I was to line all these days up in order, it'd be the middle value. So what would be very helpful to know is how many days there were in total. So we'll do 3, add 16, add 6, add 4, add 1, and there's 30. Oh yeah, of course, there's 30 days in November. Now if you were to line up all 30 days in a row, it would actually be between the 15th and the 16th value. So we call it the 15.5th value. That would be exactly in the centre of 1 to 30. So let's work out which group the 15.5th data is in. We have 3 data points up to here. We have 19 data points up to here. So the middle value, if we were to line them up in order, would be in between 10 to 20. So the answer to question A is between 10 to 20. And then calculate an estimate for the mean. Okay, well let's just rub out these little workings that I've done so far. Okay, so the mean. How do I work out the mean from a table of data? Well, I've got 3 values that are somewhere in between 0 to 10. Now, how do I use... So let's just remind ourselves of what the mean is first. The mean is add up all the values, divide by how many there are. We know that we're going to be dividing by 30 because there are 30 days in November. But what would I be adding up? I've got 3 data values that are in between 0 to 10. Now if I've got between 0 to 10 minutes, then I've got about 5 minutes. On average, if your data is in between 0 to 10, then it's going to be probably about 5. So what I'm going to do here is I'm going to work out all the midpoints for all of these groups here. That's to say that if I was to spend between 10 and 20 minutes on my phone, then the most accurate approximation there is about 15 minutes. This one will be 25 minutes, this one will be 35 minutes, and this one will be 45 minutes. Then, so we have 3 values that are about 5 minutes long. So if I now start adding these up, then if I've got 3 days in which I spent about 5 minutes on my phone, if I was to add those up, I'll get 15. If I spent 16 days on my phone for about 15 minutes each, and I was to add up all of those 15 minutes, then I'd be effectively doing the calculation of 15 times 16, which would be 240. So I'm going to do here now frequency times the midpoint. So 6 times 25 is 150. 4 times 35, I'm doing this on the calculator to check I've got this right, 140 and 45. So now that I've added them up in their groups, I'll now add the totals up to get a full added up total. So I'm going to do 15, add 240, add 150, add 140, add 45, and I get 590. So over the course of the whole month, she's probably spent about 590 minutes on her phone. Okay, so now we need to do the division, because we need to now divide what we've added up by how many days there were. So the average here is going to be 590 divided by 30. I could probably cancel out the zeros and just go straight to 59 divided by 3, which would be 19.6 recurring, so we'll write 19.7. So 19.7 minutes on the phone on average. Okay, so let's move on to the next question then. And the next question says that the frequency table shows information about the distances 60 office workers travel to work each day. Find the modal class, and remember mode is most. So we're going to find the class with the most data in, and then work out an estimate for the mean distance travelled to work by these office workers. So which group has the most data in? It's this group, the group with 20 pieces of data in. So it's the group from 30 to 40. 30 to 40. So on average, the most distance travelled, or the more frequent distance travelled, is in between 30 to 40 kilometres to get to work. Quite a long distance, to be fair. Okay, moving on to part B then. Work out an estimate for the mean distance travelled to work by these office workers. Okay, so we remember how to do this from last time. The first thing we do is we do midpoints. So midpoints first. So we'll do between 0 to 10, that's 5. 10 to 20, that's 15. 20 to 30, that's 25. 30 to 40, that's 35. 40 to 50 is 45. Then the next thing we do is we start adding up our data, because remember the mean is adding up the data and then dividing by how many there are. Now, just to go back to the question, why does it say estimate for the mean? The reason it says estimate for the mean is because I don't know the exact data of each worker. If I had the exact distance of each worker, then I could work out an exact mean. But all I know is that I have 5 workers in between a distance of 0 to 10. So I don't really know what their distance is to travel to work. They could all be 1 kilometre, they could all be 9 kilometres, but my best guess is that it's approximately 5 kilometres for the majority of people in that group. So I'm only estimating here, but I'm doing a most accurate estimation that I possibly can. So I then have to do frequency times midpoint to start adding up my data. So I'm going to start adding up 5 values of people in this group here that travel approximately 5 kilometres to work. So if I add those 5 up, I get 25. So 5 times 5 is 25. Then 12 times 15 is 180. Then 17 times 25 is 425. Then 20 times 35 is 700. And then 6 times 45 is 270. So I've added them up in their groups. Now I have to find the total. Because remember, mean is add them all up, divide by how many there are. So 25, add 180, add 425, add 700, add 270, gives us 1,600. Then I have to divide by how many people that travel to work. And there are 60 office workers, so I'll divide by 60. So the mean is 1,600 divided by 60. I could cancel out a 0 on the top and the bottom. So 160 divided by 60, so 160 divided by 6 is 26.7. And does that make sense according to the data? Well, the data's in between 0 to 50. There's quite a lot of people at the centre, around 20 to 40. Yeah, that makes sense. 26.7 kilometres is the answer to this question. Okay, moving on to the final question for this video then. The table gives information about the distances in kilometres. Darren travelled to deliver 100 parcels. Work out the distance in which, work out the class in which the median value lies and work out an estimate for the mean. So let's find out, it's 100, isn't it? So if we were to line up 100 parcels in a row, it'd be in between the 50th and the 51st data value. It's always half and then in between that one and the one above if you've got an even number. So where is that data value going to be? Well, I've got 28 data values in between 0 to 5. If I add on the next one, it's going to give me 60. So I'll have had data points 29 up to 60 in between this group. So I'll have contained the 50th and the 51st piece of data, so it's definitely going to be in this group here. So the median group is between 5 to 10. That's the answer for part A. Then let's move on to part B. And part B is asking for us to work out a mean. So we've done 2 of these already in this video. Hopefully we should be good at these by now. The first thing we do is we work out a midpoint. And this will be for the first one, 2.5, 7.5, 12.5, 17.5, and 22.5. Then we multiply the midpoints by the frequency to start adding them up in their groups. So I've got 28 data values at about 2.5, so if I was to add all those up, it will be about 70. So frequency times midpoint, 28 times 2.5 is 70. Then I'm going to do this number times this number, 32 times 7.5, and I get 240. 20 times 12.5 gives me 250. 14 times 17.5 gives me 245. And then 6 times 22.5 gives me 135. The next thing I need to do is to work out a total for all of my data added together. So 70, add 240, add 250, 245, add 135. It gives me a total of 940 kilometers that Darren has travelled to deliver his 100 parcels. So we need to then divide by how many there were. So the mean is the total divided by how many deliveries, 100. So that would be 9.4 kilometers on average that Darren has had to drive to deliver each single parcel on average. Okay, so there we are. That's how to do questions involving mode, median, and mean. So this was video 3 of 4. We've got the 4th one coming up soon. That will go through questions 10, 11, and 12 on the end of year exam. Feel free to pre-watch the maths clips here for these questions here. Make sure you write down the most important ideas on a revision sheet, and make sure you've done that for this video as well, so you've got a lovely sheet to revise for when you revise for the end of year exam. So that's 3 out of 4 done now. We'll move on to the 4th one soon. Lovely. Thanks very much for watching, and hopefully you found this video helpful.